The frequent calibration of your spreader is considered a best management practice, or BMP, in the turfgrass industry, yet it tends to get overlooked and seen as a time-consuming endeavor. The time requirement is of little concern once you become comfortable and proficient with the calibration process. Remember, each piece of equipment and each operator is different, so you're calibrating the spreader not just for the product or application site, but also for the person using it. The proper application of fertilizers and pesticides is critical to ensuring that these products are applied safely and accurately with as little waste as possible. With the method here, you should be able to quickly calibrate any rotary spreader regardless if it is mechanically driven or a walk-behind. Frequent calibration helps prevent over or under-applying fertilizers and pesticides, saving you money, protecting the environment, and ensuring legal compliance. Under-application can lead to weak turf and poor pest control, while over-application risks plant injury, environmental harm, and illegal usage. Ultimately, poor calibration wastes time and resources. Consider the following factors in determining a regular schedule of calibration for your rotary spreader equipment. Anytime you are switching to a different product, you should recalibrate your equipment. The size of the granules or prills can vary dramatically from product to product. When a new operator is using a walk-behind spreader, walking speeds can vary from person to person. When ground speed has been adjusted on ride-on or mounted equipment, remember improperly inflated tires can affect the ground speed of your sprayer. When a major spreader part has been replaced, new parts can impact application rates. When frequency of use is high, parts wear out over time and the integrity of spreader components can become compromised. You will need someone to assist you to determine the swath width of the spreader and assess the distribution pattern. Yes, it can be done alone, but it is not recommended unless you are skilled and competent with this method. The remainder of the process can be done without help. This method of calibration is designed to be done on a typical grassed surface. Do not calibrate on concrete or blacktop. You'll need the following tools to perform the spreader calibration process: a measuring device, such as a tape measure or measuring wheel. A bucket, a 4 to 5 gallon volume bucket is ideal. A scale, one that displays to 1 decimal place. Wire flags or cones. The product to be applied. A calculator. And a pen with paper. You can also use the notes application on your smartphone. In this first step, you will be using your helper to visually assess the uniformity of material being thrown from the spreader. Fill the hopper approximately 30% full with the product. Whether you're using a gate or cone dispensing spreader, move the hopper setting to the recommended number or letter found on the product label as a starting point. One person should be operating the spreader, and the other person should be some distance away directly in front of the spreader, walking in reverse as the operator moves closer. The helper should take a position about 25 to 30 feet away and instruct the operator to begin traveling at the speed that will be used when applying products and spreading the material. As the operator moves closer, the helper should be closely observing how the material is being thrown from the spreader. What the helper is looking for is to see that the material is coming out in an even arc from left to right. If the spreader is throwing heavy to one side or the other, make adjustments to the secondary gate valve or the conical distribution device. This process may take a couple of passes to adjust the pattern properly. Record the setting of the secondary gate valve and/or cone. These pattern adjustments may need to be made for each individual product being applied. Once the proper spreader distribution pattern is established, the swath width will need to be measured. The helper and operator will be set up in the same manner as before, but in this step, the helper should have one wire flag in the left hand and one in the right hand when standing at a distance in front of the spreader. As the operator begins traveling towards the helper and spreading the material, the helper should be looking both left and right to identify the extent to which the material is being thrown. A wire flag should be placed at the extreme left and extreme right of the material being thrown from the spreader as the helper approaches. It can be done in one pass, but sometimes two passes are needed, one to mark each side. Make sure to travel at the same speed each time. Measure the distance between the two flags. Record this number as your swath width. For this demonstration, the swath width was determined to be 11 feet wide. Now that we've determined our swath width, we know the measured width of our test area. Next, we need to determine the length of our calibration area. Since we're aiming to calculate the application rate per 1,000 square feet, and we've already measured our swath width at 11 feet, we can use the formula length times width equals area to find the needed distance. We simply divide 1,000 by 11 to get 90.9 or 91 feet. So the operator should walk a distance of 91 feet, measure and mark this distance using wire flags or cones. Now that we have our test area of 1,000 square feet, we need to fill the hopper with a known amount of product. Weigh enough product out so that you will not run out during the test run. 10 to 15 pounds is usually sufficient for most walking and stand-on spreaders, but larger hoppers may require more. Weigh the product in your bucket. Make sure to zero out the scale to account for the weight of the bucket. Record the weighed amount and then dump the product into the hopper. For this demonstration, it is determined that the proper label rate for the desired product is 2.4 pounds based on the need to apply 1/2 pound of nitrogen per 1,000 square feet. That formula is 0.5, the half pound needed to apply on the plot, divided by the percentage of nitrogen in the product mix, which is 21%. So 0.5 divided by 0.21, which is 2.381, that can be rounded up to 2.4. This gives us 2.4 pounds of product to be spread over the 1,000 square feet. We will now apply the known amount of product to the test area. The operator should set up a few feet in front of the flag that marks out the 91-foot test distance. Once ready, begin traveling so that the spreader's line of travel will be directly over the top of the first and second flags. Once the spreader is even with the first flag, open the valve and spread the product, and close the valve when the spreader reaches the second flag 91 feet away. Once you finish applying the material over the 91-foot test area, you will need to weigh what is remaining in the hopper. Dump the remaining material into the bucket and weigh it. Don't forget to zero or tear the scale prior to weighing. The difference between the number recorded before and after the calibration run is the pounds of product per 1,000 square feet. For this demonstration, 10 pounds of product was placed in the spreader, with 7.6 pounds being measured after the calibration test. So, we will take the initial weight of 10 pounds and subtract the 7.6 pounds of remaining weight to determine that 2.4 pounds of the product was applied correctly. If this amount is higher than your target rate, you will need to reduce the amount being spread over the test area by closing the setting on the spreader. If the amount of product is less than your target rate, you will need to open the spreader setting to apply more material over the test area. This process may need to be repeated several times until the desired rate is achieved. With many differences between applicators, such as walking pace and gate opening, calibration of your equipment for each individual is important in order to assure a high level of application accuracy. Environmental and monetary waste can be avoided with regular calibration of your application equipment.